The last time that I gave a bit of a presentation to us here, I was exploring, somewhat roughly, the directions in which the frame buffer logic lead us through for a very basic video driver, the VGA and the VESA frame buffers. Where I had first gotten my experience in that had been because I had a really cool, really hyper wonderful monitor before the era when such hyper wonderful monitors were thick on the ground, and the VESA driver didn't know how to drive it at its full capacity of pixels. Whereas, contrary-wise, the really cool video card driver that should have worked for the video card didn't quite know to do the right thing for that silly DVI-based monitor. There are a number of cool things that the video frame buffer driver brings to play, however, that have nothing to do with whether or not you have some sort of bleeding edge hardware. A previous walkthrough had been where Daniel had showed us actually adding driver to the kernel, not because it was notably different in code, but because he had determined that some sort of random boxed video card actually turned out to be servable by a driver that already existed if you added one item to the tables that drove it. How many of you are familiar with the boot up where it shows you a penguin as it's actually starting to come up? How many of you have ever seen that show you anything but a penguin? Two penguins. Anything but penguins as the pictures.
Oh, red hat, yeah.
Okay then. Well, there's a way that they did that, and that way is to actually edit the little picture that's found in the logo. The Debian and Ubuntu family of distros attempt to make it fairly easy to edit that logo, but the package that they provide to make it really easy is just going to put a little Debian squirrel in it instead. So I'm going to start investigating that and wander off into the section of the frame buffer code where it actually uses that. Because there's more than one resolution of that little logo that it actually can present to us if we happen to have a monitor that supported those other resolutions or preferred them. Now, I have this in patch form because that's the way I fetched it. And given the time that I had allotted to prepare before this presentation, this is really what I had to be able to take a look at. So in the driver's video logo kconfig area, there's various options where it says, yes, it depends on a logo. And I think this is where it's actually adding it to the listing for the menus in menu config, for instance. So that, you get added this extra option that says, do you want the open use logo or do you want the Debian squirrel?
How interesting. DEC lives on. Unbelievable.
Notice the .o files described there as an object file for it to link in. So the biggest point I see here is this ppm format is something that you can actually generate yourself. You might need to use the GIMP to generate a format that can be turned into a ppm. Right, because the netpbm library of stuff contains various types of tools that actually do that sort of thing. PBM to FB. You can actually display netpbm graphics directly on frame buffer devices it's not kernel specific, but there are some apps that can actually use that way as well. So you can actually gloss up not only the kernel's portion of things, but that's how some of them do the thermometers and the shiny things when you log in. And I think there is a login replacement called, or maybe it's a Getty replacement called Francine that does something like that.
So I was looking up there, I don't see NetPBM itself up there. Is that because it wasn't, I mean, I see shared libraries for NetPBM, but not PBM itself.
Well, it probably scrolled off the end here in the way that I've got this terminal set up is. There we go. A few things that handle various raw camera images or convert PPM to other things. When I first did this sort of adjustment, I actually had to turn stuff to an XPM, then to a PBM, then to a PPM, and then let these sorts of things use it. So let's go back over to the source here. Notice also there's a monochrome one, a 16 color one, and a 224 color one. And the way that this patch is setting it up is it's actually leaving the Tux logo available if you want to use it. So here it even says it's going to use the PNM to logo script. Now, with knowing that it's in the driver's video logo area, and there's a logo.c, now we have the opportunity to go into the Linux source area itself. My goodness, there's all these PBMs. We certainly can. This is the make file specific to those logos, and you'll see that it looks very strongly similar to the patch we were looking at because this is the area that would actually be patched to add a couple of entries. There's nothing here mentioning Tux, but the default logo happens to be Tux, so.
So this logo-c files is a program that's... So the logo-c file is a little program that is also contained within the kernel sources. It's being built with hostcc and then run on that to basically wrap the PBM or the logo file in an object header so that it can be linked into the kernel. Is this what's going on?
Yeah, it's adding just enough code to be actually choosing to display it. Here, I'll show you.
I was going to say, doesn't it show up as like a string of bytes or something?
Well, they're all extern struct.
Right, because that's the raw data of the actual picture. Bunch of bits. Logos are marked init data. Obviously, as soon as everything's done scrolling by, we're going to be throwing them out anyway. Then we have various special cases for which we're selecting a particular logo because we have to. There's the deck logo that we'd select if we were on an alpha. And the Macintosh one. And if you were really totally lazy and you didn't mind the fact that you were going to be replacing one of these files completely, You could actually just copy one of your ppms into place, completely squishing these, which means that you wouldn't be patching a whole lot at all. But one thing you'd have to make sure is that you're actually honoring similar traits of graphics to it, so you're getting what you expect.
Meaning things like bit depth and whatnot?
Yeah. You're probably not going to get a chance to choose really fancy colors unless you're replacing the 224 color logo. I forget. They decided that they like this other picture app instead. Anything that would be able to view a ppm should actually be able to show these to you. You can get a feel for what it actually looks like. If the file command were a little brighter about it, it could have told us the specs were right there.
Is there a file command that does that, or a command like file that does that? Is there a, I mean, okay.
I'm going to grab one of these at not terribly random. I'm going to assume that the Macintosh 224 one is somewhat colorful.
No, it's a picture of an old Mac with a penguin sticking his head through the video monitor.
So it's going to have some orange and a little white and some black and a little gray Macintosh around it, right?
Yep.
Are you trying to view it?
Yeah, I was kind of hoping to, but it's not actually necessary.
Do you have display on the machine?
Yeah, I was going to say, I mean, you should have something that'll display that directly.
Look it up in GIMP. Totally do it. You don't have GIMP installed yet?
GIMP came with a set, so it should be there. Ooh, isn't he cute?
And what's his name?
His name is Wilbur. No, I don't need to be shown any tooltips about how to use the GIMP. Thanks, though. Here's the little guy, only maybe that's a little small for you guys out in the audience to see. So let's get that a little bigger, shall we? At the scale that's on the size of your screen when you're booting up, he's going to look a little rounded because of all of that little bit of white and gray that they've chosen to add. That's called anti-aliasing if you're not familiar with it. There's all of these dots here, and they're slightly different colors of yellow and gold, which gives Tux his cute little duckbill. But the fact is, we could actually replace this with any picture we wanted to. We could pull down, and we could pull down a list of how many colors it's got. It actually says right here, RGB 1 layer and 80 by 80 pixels. So any 80 by 80 pixel picture would do. Most of your distributions come with a directory named user share icons full of an awful lot of pictures, most of which are actually smaller than that, but which are certainly easily scaled if you want to mess. You know, if you want it to look like a little medical bag or a Debian swirl or a boot that actually looks like a cowboy boot, or the logo of your company if it fits in the corner of a business card, that being about the size it's going to come out anyway, then you can certainly do it here. So leaving off the picture stuff and setting that aside for now, let's get back to the code and see where it is that we can see in this case, it's making sure, this is the makefile that Jim was interested in before. P&M to logo, monochrome, make this, create an object. So this is just making sure that there's actually going to be object files created that are suitable for these items down here to be created as object files. Which are going to be structures absorbed. All those guys there. As constants, they can be accessed very quickly at the startup, which is good because that makes everybody feel like their really spiffy Core Duo or AMD 64 or something like that is actually doing some work. Yay, I see a penguin, I'm getting some work done.
It's actually the graphics processor doing all the work.
Well, yes, we have these great graphics side processors that are probably brighter than our computers of 4 years ago anyway. May as well get them going too. So here in the patch for it, we're being somewhat careful to avoid stomping on the pictures that will be offered for other platforms. And then it looks like here we're actually seeing the bitmap that's going to be that Debian swirl they're trying to put in. It would probably be even easier to tell what picture it was if they'd chosen to do it as an XPM, because that's what XPMs were originally designed for, to be merged into C source code. I get the feeling that's going to become really boring quick, so I'm going to start at the bottom and go back up.
Are you looking for something? Or?
The next thing that I think would be valuable would be to see what contains logo, a reference to logo.c and actually calls on it. Because those are going to be the kinds of drivers, the video drivers that we would expect to be invoking the little penguin on your screen. It looks like it's called here from the frame buffer memory, and that makes sense because when it loads them up as a constant structure, this is where it's going to put them. And we're seeing it also mentioned in console, Fpcon. So I'm going to go there. Because what I am exploring and looking for is where's the code that actually shows us the penguin. The other part actually says these objects are going to be the logo column, whichever one we need, but what's the actual thing that makes the request? Based on the Amiga console driver. Well, that makes sense. Amigas and Ataris were perfectly happy to show us little logos when we got going. Including the fpcon.h. There's a few variables for if we really have an Atari. And there's a certain amount of fuss to make sure if we have fonts that we get to load those too. Knowing that the variable is called canShow, I can actually jump all the way down to that. So how many people look at this piece of text here, logo shown as an index to Fpcons, and think, oh man, I need a dictionary to translate that? Oh, come on. You don't need a dictionary to translate that? You don't have a dictionary that translates that. Okay, then. So the virtual console, when the option has been selected to be greater than 0, in other words, yes, we've been told we can draw it, or yes, we've been told we can show it. Otherwise, there's some sort of enumerated value, enums, that's going to say which one to load. So here, they set a variable. Well, okay, it's not very variable. It's a static that says it's being set to this. And that's just so they can refer to this logo shown in a way that, because this one here is a macro, as far as I could tell from further up. But this one here, it's a static int, so it can be used in places where variables go. Now this softback size, I'm supposing that this amount of space here is actually going to describe the memory that it needs to set aside for it. And then here, how many consoles do they have? It's setting aside some memory for each virtual console. Maybe some of you get 6 or 8 of them because you've got a bunch of ones you're going to use as TTYs, and then it sets aside some specific structures for those sorts of things. Those aren't very visual, but they're very important. So the frame buffer console is default. Here, we're using the frame buffer. We want to be able to see what we're doing. Yes, this is the way we're going to use the console. That's what that means. Since I know that logo shown was the variable we were going to talk about some more, I went looking for the word logo. Fpcon takeover. After it's ready to make sure this is the console for time ongoing, and we're going to hand off out of the itty bitty brains in the kernel space. This says if we were not registered as a frame buffer, then get out of this code right now because we just can't do it. No dev, no such device. But this here, the next line, if we don't have a value to show the logo, then change that value and say, no, we can't show it after all. And then go ahead and set a few variables here and there. Fpcon is default and some stuff like that. Error equals takeover console, so I guess takeover console is the next place for us to go.
So wait a second, what's that for loop doing?
A for loop,
To FD map?
console to frame buffer map.
It's going from first frame buffer console to last frame buffer console number.
And it's assigning info IDX to it, but
No idea where that came from.
love some comments there.
Well, that's why.
Static info IDX starts at -1. There's no frame buffer info to start. Looks like it's just setting it so that it can use it later to create a new one.
IDX probably stands for index,
Yes.
and so saying the no index. Maybe they're gonna set it later. I wanna make sure it's clear.
Maybe they're just marking it as a flag for which ones have I drawn it on, or something like that.
Initialize.
More like, have I actually initialized these yet, is what I'm thinking. Instead of blindly using register to FB, we use info IDX set by FB console init, it says right here. Essentially, this is saying that just because the code has registered itself as suitable to this task doesn't mean it really was going to do it. So we separately set ourselves a little flag to check if we really got to looking at that yet. And then if our little flag says it didn't handle it, or this other thing that came from another direction is null, then that's it, we're out of here. Not surprisingly, this is pretty close to a blurb that's controlling whether to make sure that we don't show a logo when we really can't. Finally, we get to a part where we're being asked if we can show the logo. And if we do that, then we're doing this Fpcon prepare logo, where we get given all of these variables about how many columns and rows there are. Up here, that's a static void. How many of you are familiar with the C construct of a static void? Some of you seem to be very familiar with it. Others of you seem to sort of not be so sure. You want to take an educated guess and see if we can help you out with really understanding it? About the static void.
Describe a static void in 25 words or less.
Except that we want to
function.
capture.
Well, is this a function?
Yes, that's a function,
Does not return, void does not return a value
and it's also only visible to,
in the local lexical scope. So, or only visible within the current compilation module.
Which is very handy for the fact that most of this is code that's going to be scrapped later. But we get all these variables for how much rows and how much columns we're going to use. We make a little bit of room in memory for the logo. We erase some space to physically put the logo on your screen. We double check a trait to make sure that it's going to be okay to show the logo, and if it isn't, then we bail. So there's lots of places where we defend against accidentally showing the logo. Remove underline attribute from erase character if it's a black and white frame buffer. There was this really weird trait back in the old days where if you had a black and white monitor and it was sent various colors, it would be white all the time and that would look fine, except if the color that it was sent that it wasn't able to show you was blue, that it would show you underlines. I'm guessing that somebody's black and white frame buffers out there have some sort of strangely similar trait. You need to make sure, in this case, that you're not going to get these streaky lines across the space that you just carefully blanked out with space characters. Otherwise, Tux is wearing bars. So having successfully gotten rid of that, then we've got some height, we got some lines. This looks like it sets aside some memory. And this actually copies some memory into the place we were just messing with. Having done a couple of things here, it's safe to scroll our screen down. And I think that some of this code has to do with the part that defends it against scrolling the penguin off the screen while the various messages of the kernel are still going on. So the console is visible, and we're doing all this stuff with text. We clear the margins, we update the screen. We're making sure that we have our lines worth of the logo. And then we're done. So that's the portion that either displays the boot logo or about a dozen times over, it looks like, make sure that we don't display the logo if we shouldn't be allowed to.
And only if it's not a module.
Right. If your frame buffer status is established via a module, you're way past the point that's the beginning of the system, and it's not interested in showing it to you then.
Right.
You could go get the PPM and use one of the frame buffer display apps to show yourself the picture then. There may be other sections in this particular section of code that may be interesting to some of you. Have any of you explored some of these video sections of code during the Christmas break? It looks like very similar constructs in memory were used to capture these fonts. Usually, you're only going to compile a few of these fonts into your kernel, the ones that are suitable to your particular environment. But I have done unusual things like set myself up with the Sun font because it's got a lot more pixels in it. And yeah, its aspect ratio looks a little bit weird, but it's pretty. Oh, I do this very strange thing. When I make menu config, I like to actually sweep through all of the options, reading all their little help blurbs. And the help blurbs under the VESA and VGA buffer stuff actually include some notes. Let's see here. Well, in order to really make menu config, I'm going to have to go up a couple levels here. So hold on a sec.
I hope you have all your dependencies.
Of course not.
Actually, you have to become root in this case. You're getting permissions errors.
Probably not.
This is a brand new laptop to her, so she has got a lot of stuff not installed.
Yeah, and probably if I move this actually about 3 feet, I'm going to lose the link that lets me do stuff. I'm guessing it's actually libc6.dev, dash dev.
What are we trying to do?
The following extra packages will be installed. Linux-libc-dev.
You
We don't need
to-
those silly
you
man
need to
pages anyway,
install
do we?
libncurses 5-dev in order to get menu config, if that's what you were trying to do.
Yeah, but that might actually be one of the ones that made it.
5-dev.
I think if you install the.
That's the only one. That's the only one that's missing by default on Debian.
I already installed kernel-package, but that doesn't force me to use a graphical or a cursor addressable mode. And I'm really not interested in going through a beautiful pile of help pages in line-by-line mode. You can go crazy that way. zconf. Ooh. This is really an extremely limited and tightened up version of dialog or whiptail that they crammed into here and carved every nickel shaving off that they could. I'm not entirely sure quite why they bothered to tighten it off quite that much, because it would have been pretty handy for them to just depend on the main package. And I mean, whiptail isn't that big. But to give an example, here we are at some random thing like appending version information. If we go into the help, then there's some notes about this particular item that you can say that there's a local version value and adjust it to any text you want. And the device drivers here, somewhere near the bottom, because they're sort of almost kind of sort of graphic support. There we're going. Display devices. Console display. Boot up logo. That's what we were looking at. Help. Well, select some sort of frame buffer logo. This is that part about the has this and yes that. And we have more options, a standard black and white logo. And the result of that patch, if we applied it successfully, would be that there would be some more options here for us to checkbox.
Including like a file name, a place where you can put in a file name to the
Oh, that'd be too
Let's
easy.
apply the patch.
If I remember right, it's -P1. This is basically carving one layer off of the directory structure that's on the names of the tab of which file is being patched. We need to do that because otherwise it would try to have exactly the same version number as whatever the person who made this patch was. That was something like 2.6.17. So it bounced along, grabbing a hunk here and a hunk there, applying it. And now, if we make menu config, and we go into exactly the same place as before.
One comment from the peanut gallery. After I apply patches, Now that one was really short, so you could see everything on the screen, but usually they like scroll off with hunk this, hunk that, and everything. So right after, every time I apply a kernel patch or any kind of patch to a source tree, I do a find dash name star.reg, R-E-J, to look for rejects and then go and untangle those before I take another step. And I always make sure that the entire tree is free of, .reject files before I apply the next patch or before I even try and do anything else.
I agree. It's very common for these diff files to have something that slides around slowly over time. And what's really frustrating is when something will only apply if it's within 5 lines either direction. And there it is, it's like 7 lines off. And you're like, I can see it right there. Why didn't you do it? But at least those are easy to apply by hand. And then you can, and it applied what hunks it could. So out of, I don't know, 27 loose pieces, you only had to do 1 or 2.
Yeah, most of the unidiffs seem to apply cleanly within 100 lines or so of context. But sometimes the kernel developers like to take whole swaths of code and
Well, that's
refactor it
pesky
over to a whole
refactoring
different
into
file
a
somewhere.
subdirectory.
Exactly.
So here we have had 2 options added, a Debian GNU Linux Open Use logo, that's the squirrel. And this is a Linux logo with the Debian squirrel, which I think is maybe Tux with a squirrel on his tummy or something like that.
Heather?
Short note, for using patches, does anyone here do their kernel patches without using Quilt?
Without
you do-
using what?
Without using Quilt? If you don't use Quilt to do what we just did, then you enjoy pain.
Or we're just ignorant.
Quilt is good, but Git can also be used for that kind of thing if you use something like Gilt. So Git.
Guilt or quilt?
Yes, Gilt is like Quilt built on top of Git. So
So there's no need to feel guilty. Go get Quilt and use it.
I think we need somebody to get up and do, on some other talk, to do a full Git demo.
okay,
Hands-on, show us the whole mess.
okay.
You know, that would make a good topic for the main speakership.
I don't know. I mean, I'm from the Stone Ages. I've never used Git.
I just started.
So, still being here in the Stone Ages, this tiny little patch that was so small that we could read it in less than 15 minutes sitting here scrolling around in silly little GNOME terminal, no, it did not add an actual text box for you to type into. Let's see if it actually added a help blurb, though. Why, yes, there's no help available for this kernel option. Then you get a list of the kinds of default things that go with that item. But it does go into the boot up logo area. If you say yes to boot up logo, then this is an option that begins to be shown to you. I find it curious that it didn't bother to repeat downward the item that it had from the section above, but the menu config style of dialog doesn't have that sort of smarts built into it. Anyways, enable and select framebuffer boot up logos, and we now have 5 instead of previously having 3. Because the patch is actually sufficiently simple in structure, it would be extremely easy for someone to take the same patch, add another section to it just with a text editor that added even more text and added another 2 or 3 logos that they really liked. How many of you have actually been watching these kernel walkthroughs from the beginning? I know a few of you have. Cool. Is there any particular topic within the kernel that you think would be worth exploring next, or at least starting to take a look at?
And
Looks like he has this. That's good. I've never been to one of these before, but the question,
Hey, leave them alone.
and I looked on the webpage and couldn't find, like, there's a wiki and it had sort of an outline, but I couldn't find a list of which topics have been covered and where we were. So,
That would be because the people who have been presenters so far haven't gotten around to editing the wiki page further.
okay.
We've just started this. If you've got a topic of interest, it's probably hasn't been, that's got significant meat to it, probably hasn't been jumping too much.
IP tables, net filter, and contract?
Oh, we definitely haven't been into that yet.
Not going anywhere near the networking code.
Okay, maybe that should wait. I don't know.
You can do it on
It's,
Tuesday.
Hey, leave them alone.
You got it, John.
An introduction to the names would be nice. Just the landscape. Here's what it is, here's kind of what it does.
like a conceptual overview. It's not, wouldn't be worth it to go through line by line the contract code because it's,
I would love that.
oh, well, could do that too.
Some of us have taken this presentation from one direction and some from the other. Some have started at the very low level, what's really going on inside the tiniest little nook of a brain cell of what the kernel's up to, and try and advance outwards towards something that we can see. Some others of us have been looking at it from the point of view of, here I am, a human being in front of this machine. I know that the kernel is responsible for driving a bunch of under-the-hood elements of the poor little car I call my laptop, but what is it that it's really doing when it's doing this visible thing? Now, some of these visible things are much more complex than can be covered in one evening, such as mounting a file system. Well, okay, so the mount file system call is, the mount system call goes into this direction, and the file system drivers are actually built over a virtual file system, and we haven't even explored that section either. Similarly, sockets logic could easily go diving into the networking code, and the networking code has certain core stuff that's shared between Ethernet drivers, and we haven't been there at all, not even for as simple as looking at the loopback. But because we are all interested in how things really tick, I think that it's worthwhile to take an interest in those things which we tend to use day to day and wouldn't think about if they were, maybe basically unless they were failing us. If I couldn't see my screen, it wouldn't matter if the VGA plug would connect up to it. But I think that it's a lot of fun to be able to compile my own kernel for my laptop that leaves out all those silly options for all the types of device that I really don't have in here. I'm not adding a fiber array. I'm not adding a RAID 6. I'm not doing all these other things. I can save myself the space of them ever being looked at and speed up my kernel's load by at least twice the speed, maybe a little more. And if I'm going to customize it anyway, it's easy enough for me to drop in a replacement logo and have it have my shiny 8-pointed star.
Well, my general tendency is just to build a whole bunch of things as, Well, my general tendency is just to build a whole bunch of things as modules and have that take care of the memory footprint of the kernel, and then I can change my mind much more easily at a later date.
Even then, you have the advantage to be able to leave out an entire subsection if you know they're not going to work on your device anyway.
Well, there is that.
Then there's the combined approach. Build everything you do build as modules. Build not the modules you don't use, and when you need them, build them and load them.
This is true. That gives you, if you're sticking with a particular version of kernel for a long haul, It also gives you a fixed location on which to apply your patches to when you're going to do some additional strange things. If there's some really cool new form of device that comes out and somebody out in Czechoslovakia's, Sousa's got some really cool developers out in Czechoslovakia. That's where the USB stuff all came from. Maybe out there, somebody's only got the patch up on their website, and they've got a note up that says attached to it, you know, I just got a hold of this thing, and I fried 2 of them before I got the driver working. Let me know if you fry one or if it works. If you want to try that, then you've got a baseline to be able to work with. You can make yourself fresh copies of the kernel source over and over to apply things differently.
Would some of this be easier with an exokernel or something more modular?
Well, then we'd have to change the name of the study group, wouldn't we?
There have actually been arguments at some of the Usenix conferences and so on about whether or not drive towards a microkernel or a different kind of kernel architecture would be interesting. But for the moment, that actually wouldn't be a Linux kernel without some considerable effort and interest into a direction which is a little unusual. And I'm not sure, but I think that the focus of this group is to get a grasp on what it already is before changing it deeply.
There are related projects like the L4 Linux kernel.
It's pretty much already said.
The L4 Linux kernel.
The L4 Linux kernel is a port of the Linux kernel to the L4 microkernel. And it's, I think they keep it pretty up to date. I mean, the L4 is a research project on a high performance, very small microkernel. I think it's almost small enough to fit in like a cache line or something. I mean, it's pretty ridiculous.
Isn't our herd currently hosted on L4? That project?
That's stalled. Well, oh, did it actually? No, it didn't die. I'm sorry. I'm sorry. It didn't. To say that it died isn't entirely accurate because what they've done is they've decided to use something else called Koyotos, which is another microkernel, which is like the successor.
Oh, okay, so it
Which
used
is
to be
the
hosted on L4.
well, they used to want
the herd is no
let's say-
longer thundering, and there's this other thing that ran off with all its parts.
So right now, Herd works on the GNU microkernel, the GNU mock microkernel. What they wanted to do was port it to L4 because L4 has much better performance. That never happened, and now the people that have been doing L4 have been building this new thing called Koyotos that uses that's supposed to be completely verifiable, and it has, you're supposed to be able to formally verify the code.
They're using
Because
Spark
they're
or
using-
something?
No, they're using, for the lowest level stuff, they're using something called BitC, which is like a modified C for bit level operations, but looks like Lisp according to our friend over here. But they're building this new thing, Koyotos, which is supposed to be much more secure, and it's a research project, but the herd people that have wanted to move to a new microkernel have decided that instead of moving to L4, they might as well, since no work has actually been done, they're going to target Koyotos instead. Is that a fair description?
That'll be shipping with Emacs version 22 or 23.
I am done with this portion, and if we have enough time and someone has some interest in a specific direction, I would be glad to wander in that direction as well. No, I don't have any mock source code on my laptop today.
I mean, it's more micro than Linux, but it's not what is considered the latest generation serve off because they didn't find. Well, it's not just that they didn't realize how small you could actually make your and how small you could do it with very.
I think it's very appropriate in the current day and age that if we can, I think it's very appropriate in the current day and age that if we can fit a decent little, well, okay, very little Linux kernel into a gum stick or a small pack of cigarettes or a matchbox, well, okay, they're really working, and they're still working on the matchbox thing, but they could definitely get one into a small pizza box, man.
You were talking about possible topics, and one of the things which I did paste into the wiki as a possible future topic was some links into kernel trap discussions, and what they do is they're basically commented and captured email threads off the kernel mailing list. And there was a fairly recent one in which a number of people, including Linus, talked about how to analyze an oops message.
Ooh.
And
That sounds like
talks
fun.
about things like, Linus's favorite technique is to basically capture the little code dump, the recent instructions from the bottom of the oops message, and he basically defines a string with that, and then he compiles just a little tiny C program that contains that, goes into GDB, does a dump of that to capture what the assembly code for it is, and then he analyzes that. And it goes into detail about how he does it, and then a few other kernel hackers like Andrew Morton, I think, chimed in with, oh yeah, but Linus, that's a silly way to do it. Here's an easier way to generate the assembly code, for example. And so it's a thread that is absolutely well worth reading. So.
On that same note, there's also a really good write-up of it on Kernel Trap, I think.
That's
So-
what I just said.
oh,
The links are to
sorry.
kernel
I
trap,
thought the
and they were extracted from the mailing list.
my brain is dead.
Okay, so we've determined that his brain has gone the same place as the wireless connection went.
Oops.
Well, that gives us, sounds like 3 topics. So potentially 3 weeks worth of talks.
One of them sounded like it could easily be more than one.
Well, and then somebody would have to, like, bone up on the oops stuff.
In the sense of if you're going to add anything to your kernel, knowing how to tell that it's really screwed something up so you can unscrew it up, that actually sounds quite tasty. Also, if you haven't done anything to it, or at least you don't think you have, but you'd like to know exactly what to file in that bug report so that maybe they'll actually fix it, this has got to be the good way, because if you can, about the fastest way to get a developer to say, all right already, and just fix it, is to submit your bug report with enough detail to be able to reproduce it even if they haven't got your machine, and a patch. Probably the first thing they'll do is they'll look at the patch and they'll go, this is terrible, ah! And they'll go looking at how it is that they could reproduce this thing. And then either they'll say, yeah, I guess that's the right patch for it after all. It's terrible because my code was terrible. Or they'll say, no, 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 this is horrible. It's a terrible design. It's just like the such and such over. Oh, wait, that one's broken too. And the next thing you know, you got 3 or 4 things all fixed because they all had the same nature of a problem. When I was first involved in the Moin Moin project, which isn't kernel related at all, it came out to something almost exactly like that. I was chasing down some stuff that was hard-coded in the code. So, I mean, I was happy enough with my results, but I did tell the developers what it is that I'd found, and the first thing that they did was they turned it into table-driven code so that all of those options chased down in various scattered portions of the code all referred back to one place. Then if we wanted to change them all at once, type, 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 we'd change them all at once. Very valuable. It looks like I didn't quite bring as much material as would fill the portion for this evening. But I think that this is enough to wrap for tonight. And I encourage people to come and chat with me afterwards or anything like that about any other bits of this kind of cool stuff.
Thank you very much.